Long before the supercontinent Pangaea dominated our planet, Earth was a vastly different world. Imagine a blue marble, almost entirely covered by a global ocean, its atmosphere thick and its climate extreme. This ancient Earth, a true water world, set the stage for life's most profound transformations. To truly grasp the monumental shift from water to land, we must first journey back in time. We will explore the planet's earliest conditions, the evolution of its primordial seas, and the incredible life forms that thrived within them. This deep dive into Earth's past reveals the context for one of life's greatest adventures, the move onto solid ground. In Earth's infancy, during the Hadean and early Archean eons, free oxygen was virtually non-existent. Any oxygen produced by nascent microbial life was immediately consumed by reactive minerals and gases. This anoxic environment persisted for billions of years, shaping the planet's early chemistry. Then, a pivotal moment arrived, the Great Oxidation Event, roughly 2.4 to 2.0 billion years ago. Atmospheric oxygen levels began to rise, from less than 0.001% to perhaps 1 to 10% of today's concentrations. This dramatic increase fundamentally altered Earth's surface and atmosphere. Throughout the Neo-Archean and Proterozoic eons, oxygen continued to accumulate in pulses. These gradual increases were crucial, slowly setting the stage for the emergence and diversification of more complex, multicellular life forms. The air we breathe today is a legacy of these ancient biological revolutions. Early Earth was a planet under a perpetual greenhouse effect, driven by thick atmospheric water vapor and carbon dioxide. Models suggest near 100% global cloud cover during deep time. This dense blanket trapped immense heat, creating a hot, humid world. Such high greenhouse forcing led to frequent, planet-encircling deluges. These were not gentle drizzles but intense storm cycles, delivering vast amounts of water in localized bursts. The very air was saturated, contributing to a relentless hydrological cycle. The formation of Earth's oceans began around 4.4 billion years ago, as the Hadean magma ocean cooled. Water vapor, released from volcanic outgassing, condensed and fell as rain. Evidence from ancient zircons confirms the presence of liquid water on the surface by this early date. Estimates for how these vast basins filled vary. A classic runaway greenhouse model suggests centuries to millennia of near-continual rain. This would have been a truly epic downpour, slowly but surely filling the planet's depressions. Alternate models propose a different scenario: intermittent, intensely powerful storms over tens of millions of years. Regardless of the exact mechanism, the result was the same: a planet dominated by a single, interconnected global ocean. For billions of years, microbial life reigned supreme in Earth's oceans. Stromatolites, layered structures built by cyanobacterial mats, were ubiquitous from the Archean through the Proterozoic. These ancient reef builders were among the earliest visible signs of life's profound impact on the planet. Later, during the Ediacaran period, roughly 635 to 541 million years ago, a new form of life emerged. The Ediacaran biota comprised large, soft-bodied multicellular organisms that colonized shallow seas. These enigmatic creatures represent an early, experimental phase of complex life. Then, around 541 million years ago, came the Cambrian explosion. This sudden appearance of nearly all modern animal phyla marked a dramatic diversification of life. Trilobites, archaeocyathids, early mollusks, and echinoderms rapidly filled the marine ecosystems. Crucially, the first chordates also appeared during this time. These early forms, possessing a notochord, hinted at the evolutionary path that would eventually lead to vertebrates, including ourselves. The Cambrian seas were teeming with novel body plans. The oceans of this era also saw the rise of formidable predators. Anomalocaris, a Cambrian arthropod up to 1 meter long, was an apex predator. It wielded grasping frontal appendages and a circular, toothed mouth, making it the terror of the early seas. Millions of years later, in the late Devonian, Dunkleosteus emerged. This plated arthrodire placoderm, reaching up to 10 meters in length, reigned supreme on Devonian continental shelves. Its powerful jaws and armored body made it an undisputed king of its domain. early marine food webs were initially simple, centered on the microbial loop. Cyanobacteria formed the base, consumed by microzooplankton, which in turn fed filter feeders. This fundamental cycle sustained the earliest ecosystems. As life diversified, small predators like worms and early arthropods joined the fray. These creatures hunted smaller invertebrates, adding new trophic levels to the developing food webs. The complexity of marine life was steadily increasing. The emergence of large predators like anomalocarids marked a significant shift. They were followed by early fish, then placoderms, and eventually lobe-finned fish. This progression illustrates the escalating predator-prey arms race that drove much of marine evolution. The Devonian period witnessed an incredible diversification of vertebrates. Jawed fish evolved into ray-finned and lobe-finned species. This crucial evolutionary branching set the stage for the eventual path toward tetrapods, the four-limbed vertebrates. Shallow continental shelves were the biodiversity hotspots of these ancient oceans. Their sunlit waters and varied substrates provided ideal conditions for life to flourish. These vibrant ecosystems were nurseries for countless species. However, these ancient seas were not without their dangers. Periodic anoxic events, where oxygen levels plummeted, caused widespread extinctions. Rapid acidification from volcanic carbon dioxide also posed a constant threat to marine life. Killer storms, driven by the planet's intense climate, ravaged coastal areas. And the relentless predator arms races meant that survival often depended on evolving new defenses or more effective hunting strategies. Life in the ancient oceans was a constant struggle. The monumental transition from water to land began in earnest during the late Devonian period. The first tetrapods, four-limbed vertebrates, appeared around 375 million years ago. Their fossil remains are found in ancient river deltas, hinting at their semi-aquatic lifestyle. By the Carboniferous period, around 340 million years ago, early amphibians had diversified significantly. They thrived in the vast, swampy forests that characterized this era. These pioneering land dwellers gave rise to all modern amphibian lineages. Several key driving forces propelled this extraordinary move onto land. One significant factor was the escape from predators and intense competition in crowded reefs and rivers. Terrestrial environments offered a refuge from the relentless pressures of aquatic life. New food sources also beckoned from the land. Early insects and primitive land plants provided an untapped bounty of nutrients. For those brave enough to venture out of the water, a feast awaited. Environmental instability, particularly the drought of ephemeral pools, played a crucial role. As water bodies dried up, aquatic creatures were forced to seek new sources of water. This pressure drove the critical fins-to-limb transition, enabling movement across land. The move onto land required a suite of crucial adaptations. Lobed fins, already present in some fish, evolved into robust limb bones. These new structures were capable of bearing weight on soft substrates, allowing for rudimentary locomotion on land. Primitive lungs, derived from the swim bladder of fish, became essential for gas exchange in air. Additionally, cutaneous respiration, breathing through the skin, supplemented oxygen intake. These dual systems allowed early tetrapods to survive out of water. Sensory systems also underwent significant shifts. Eyes and ears adapted for aerial detection, crucial for navigating a terrestrial environment. Internal ear structures evolved to provide better balance, a vital adaptation for moving on uneven ground. The journey from water to land was a testament to life's incredible adaptability.